Hello friends, Namaskar.
This is Arkansas Free Education, chapter number 13, 10 Science.
Dhanyavad. So now let us talk about the magnetic effects of current, right? But before discussing this, let us first understand what are the electrical effects. What are the effects of electric current? So there are heating effect, chemical effect, electric shock effect, accidental fire due to short circuit, psychological effect and magnetic effect. So these are the different effects of electric current. But now in this chapter, we are going to focus about the magnetic effects of electric current. This gentleman, Hans Christian Oersted in 1920, observed that whenever there is a current carrying conductor placed, then there is a deflection of magnetic needle. It clearly indicates that some sort of relation exists between electricity and magnetism. When he switch on the supply, magnetic needle deflects. When he just interchange the polarity, he reverses the polarity, then the current used to reverse, and the direction of deflection of magnetic needle also gets deflected in reverse direction, right? So this clearly establishes a relationship of magnetism with the electricity. Now it is very clear, and we have already studied in the previous standards, that magnet have north and south poles. Magnetic lines of force emerges from the north pole and terminates at the south pole. Inside the magnet, these magnetic lines of force travel from south to north. Magnetic lines of force never cross each other, they never interact with each other, right? And magnetic field strength will be maximum at the poles and minimum at in between. As we go away from the magnetic strength will go on decreasing. These are the properties of magnetic lines of force which we have already studied in the previous standards, right? And this gentleman, Michael Faraday, the father of electricity, what did he say? He said that whenever we are moving in or dragging out, moving out a magnet towards or away from a coil, then a current induces in that coil. So this definitely establishes a relationship that magnetism also interacts with electricity. Means electricity and magnetism, they are nothing but just like Sita and Gita of Gita and Sita picture 1970, Hema Malini. They are nothing but a common person, Hema Malini. Or electricity and magnetism, they are simply two forms of energy, that is electricity plus magnetism, and combinedly they are known as electromagnetism. Now let us understand about the magnetic field due to current through a straight conductor. Whenever there is a conductor, now current is passing through it, then the current which passes through this conductor will produce magnetism, and the direction of those magnetic lines of force will be represented by the encircling fingers of right hand. Repeat. Current carrying conductor produces magnetic lines of force. If current is given by thumb, then encircling finger will represent the direction of magnetic lines of force. And this rule is known as right hand thumb rule. This rule is known as right hand thumb rule. Now, if there is a big conductor, straight conductor, and if we just go on bending this straight conductor, right, what will happen? It will have a ring-like shape. Suppose this is the direction of current, then according to right hand thumb rule, this will be the direction of magnetism which have been produced by this electric current. So if it is a circular in nature, it is very easy to find out that the direction of magnetic lines of force can be given with the help of the right hand thumb rule, right? So this will be the direction of magnetic lines of force. Now what is solenoid? Solenoid is nothing but a piece of iron on which certain copper wires have been wrapped in ton by ton. And if we now pass electricity in those tons of wire in those coil, then if this is the direction of current in those conductors, then the magnetism which will be produced with the help of these conductors will have direction like this. Means north will be here and south will be here. That can also be represented with the right hand. Now, when a copper coil is wounded ton by ton on an iron bar, on an iron nail, then this nail behaves like a magnet. So, when a current carrying solenoid coil is used to magnetize the steel rod or iron rod inside it, it behaves like a magnet and it deflects the magnetic needle. Why? Because now it has become a magnet, and this magnet which has been artificially prepared, that prepared magnet which has been prepared with the help of the electricity, is known as electromagnets. So electromagnets are nothing but artificial magnets prepared with the help of electricity, and those electromagnets are having many applications in real life. For example, this crane, it is using electromagnetic principle to lift the scrap of iron, right? Now force on a current carrying conductor if it is suspended freely. Now what will happen? It is very clear that whenever there is a current carrying conductor, it produces magnetism. Now if we bring another magnet toward this current carrying coil, then the magnetism which will be produced by the conductor or current carrying conductor will interact with the new magnet, and due to interaction they may attract or repel, means some sort of force will be exerted due to the current carrying conductor and a magnet. Repeat, magnet will exert a force on a current carrying conductor, and that force can be found out with the left hand rule. We will discuss soon what is the left hand rule. MRI, our body is also in some sort of magnetism. This magnetism, when interacts with the magnetism of this machine, certain types of the images may be produced, and this may be used to calculate to see whether any deformalities are there. So doctors may use this image to find out any disease or not. This Antarctic tern and these flamingos, they actually travels from hundreds of kilometers and go back again to the same nest. Why? Because of the magnetism. In short, magnetism, magnetic lines of force of earth, plays very vital role in human as well as other animals. Now what are the motors? Actually, motor is an electromechanical device which converts electrical energy into mechanical energy, into a movement, into rotation, right? There are two types of motor, AC motors and DC motors. AC motors runs on AC supply, that is alternating current, and DC motors run on DC supply, right? So this is an electrical motor which we generally use in our household applications for lifting water from sump or bore. Now what is Fleming's left hand rule? Fleming's left hand rule indicates that if first finger represents magnetic field, forefinger, central finger represents current, then the movement of conductor due to this magnetic field will be given by this thumb. The direction will be given by this thumb, provided all these three fingers are perpendicular to each other. And applying this Fleming's left hand rule, it is very easy to find that if a current carrying conductor or coil is placed inside a magnetic field, then it will exert a force due to magnetism and it will start rotating like this, right? So next, electromagnetic induction. It is very clear that whenever magnet is bring towards the coil, then or away from the coil, then some sort of current will be produced inside a coil, right? This is nothing but a electromagnetic induction. That current can be detected with the help of the galvanometer. So galvanometer is a special meter which is used to detect the direction of current or presence of current in a circuit. Now this, when we pass current in coil 1, magnetism will be produced. This magnetism will associate itself with coil number 2, and due to this magnetism, coil number 2 will produce electricity. Means coil number 1 will induce current in coil number 2. This is known as electromagnetic induction, because there is a transfer of energy from coil 1 to coil 2 through electric and magnetic transversal of energy. Now what is Fleming's right hand rule? Fleming's right hand rule, just like the left hand rule, forefinger field, central finger represents current, CEC, FF field, and thumb M represents the motion, movement. If we are having movement of a conductor, right? If we are having movement of a conductor, then the current which is generated may be represented with the central finger. The direction of the current generated can be found out with the central finger current. And if this is the direction of field. So these three fingers if placed perpendicular to each other, then it is very clearly that in case of electrical generator we can find out the direction of current generated. You yourself will have to try to visualize and find out the direction of electric current generated in the generator. In this is the way, वो अगर हम नाचाते रहेंगे किसी coil को तो अपने आप current वो generate होता रहेगा. So mechanical energy is converted into electrical energy. So now we may define that is generator is a device which converts mechanical energy into electrical energy, whereas electrical motor is a device which converts electrical energy into mechanical energy. So they are generator and motor, they are opposite to each other. Now the topic domestic electrical circuit, that is commonly known as wiring in our house, right? Actually group of or mesh of or network of wires are there in our house, and all these wires are commonly known as wiring. Presently in whole over India, 230 volt 50 Hz single phase supply is in practice. Protection purpose we are using MCB, that is miniature circuit breaker and fuses. All circuits are connected in parallel. Why? So that each and every item gets 230 voltage, right? Now these are the three wire color codes which are generally used in our houses. Red color is generally used for phase or live wire. Electricity used to come in the red wire, and black wire is generally used to give out the electricity from our home or our room, right? So in red, live wire or phase wire, black go back. Generally it is known as neutral wire, and green wire is known as earthing, which is connected to the metallic part of electrical object, so that in case of short circuiting the current will bypass through this green wire and will be earthed. Now there will be two wires from the electrical pole to our meter. From meter it will be going to distribution box. From distribution box to a pair of wires, two wires will be going in each room, and these two wires will be connected to each and every equipment along with the switches, right? And another third wire will be connected to each equipments on the periphery or metallic part, so that in case of the short circuit current bypasses and we ourselves remain safe. Now what are the types of circuit? There are two types of circuit: lighting circuit and a motive circuit. Lighting circuit is generally used for lights, fans, etc., small lighting loads, and motive circuit generally used for heavy loads like geyser, heater, fridge, pump, AC, etc. Earthing is generally used for earthing purposes, for the ground purpose. In case of the short circuiting, the current will bypass to the earth through the green wire, and earthing will have very low resistance, as good as 1 or 2 ohm, almost 0 ohm, ideally at least. How? By means of charcoal and salt. Salt and charcoal are placed inside the earth pit, and that green wire is connected with this earthing. Now fuse is a protected device which is widely used since hundreds of years, and it was invented by Thomas Alva Edison, right? And it uses a very thin link of a wire which is having very low very low melting point and very high resistance. So in case of excessive current due to I square RT heating, it will be too much heated, and due to its low melting point as good as nearly 200 degrees centigrade, it will melt away. So that in case of emergency, in case of short circuiting, very high amount of current will be passing. Due to this high amount of the current, I square RT heating will be there, and due to this heating, the fuse wire will melt away, and thus the current will break, the circuit will break down, the wires will break down. Okay, now let us talk about the overloading and short circuiting. These two terms are often misunderstood or confused. So let us first talk about the overloading. If you are in capacity of lifting 10 kilograms, you'll happily lift. Oh, it's quite good to lift 10 kilograms. But what will happen if somebody is simply start on increasing, if somebody keeps on increasing load on you, you will start buckling down. Oh, I'm not able to lift anymore, and you will collapse. Same thing happens with the electrical circuits. If it is having capacity of taking 5 ampere load, and if you keep on increasing its load, if you keep on increasing various items, AC, fridge, heater, वगैरह, then what will happen? The current capacity of wire will be reached and wire will start burning out. We may say that in that case, that is overloading on those wires. So what is overloading? Overloading is nothing but excessive load, accessing electrical items on the same circuit, due to which the wires may start hitting. That is known as overloading. And now what is short circuiting? Short circuiting means short circuit. It is by mistake, or sometimes due to heat, etc., or sometimes due to atmospheric conditions, phase and neutral touch each other, and hence direct current will start flowing from phase to neutral, and or may say direct current will start from positive to negative, or phase to neutral, or red to black wire. Then what will happen? A very heavy amount of current will be passing through it, and due to this heavy interest of current, the item may get damaged. We ourselves may get shock. Our item may get fire. Whole building may collapse into fire, etc. So that is the difference between overloading and short circuiting. In case of overloading, electrical items will be much more than what the capacity of wire is, whereas in case of short circuiting, phase and neutral might have touched due to any reason. Now the last topic, that is what is Fleming's left and Fleming's right hand rule. You will have to remember, otherwise you will yourself will have to devise a method to understand and memorize these two rules. It is often confused where to use left and where to use right hand rule. Let me give some clues. But before that, let us try to understand left hand and right hand rule. So forefinger represents field, central finger represents current, and thumb M represents the movement or motion. These three fingers should be kept perpendicular to each other in both the hands. And generator, in case of generator, we will have to use the right hand. In case of motor, we will have to use the left hand rule. Gujarati people may remember as generator ma jamno, just like Jethalal in Tarak Mehta Ka Ulta Chashma. Mehta Sahib is the right hand of Jethalal, fire brigade of Jethalal, jamno haath of Jethalal, right? But other people may remember as Graham Bell. Graham Bell, who was that person? He was the inventor of telephone. He was the discoverer or inventor of a telephone, right? And his name was Graham Bell. The alphabets of Graham Bell may lead us to easily remember which hand is to be used, which rule is to be used where. For example, GR, Graham Bell, GR, generator, right hand. Motor left, Graham means M, Bell, la. So motor left, generator right, Graham Bell. See, this method I have devised by my own way to remember, to memorize this left and right hand rules, right? You may devise your own way to remember these two rules. I hope you might have understood what the magnetic effects of current are. But before ending the chapter, once again I would like to remind you that in case of the motor, conductor is exerted force by the electric current and magnets, right? So movement will be there in case of left hand rule or motor. Motor is what? Electromechanical device which converts electrical energy into movement or mechanical energy. And generator is what? Generator use mechanical movement of rotational motion of energy or mechanical energy into electrical energy by producing electricity. So we are using right hand in case of the right hand rule in case of generator, and left hand rule in case of motor or movement. Thank you for watching.